Okay, welcome back. In this video, we are going to go through some examples applying our algorithm for rounding and using the designations that we went over in figure 1 to refer to the decimal places. So taking a look at example 1.1, it says round the number 397.4956 to the third decimal place. So the third decimal place is the third digit after the decimal point, and in this case that is a 5. That is what we call the round 2 digit. So let's follow the algorithm now. Step 1 says look at the number in the decimal place directly to the right of the round 2 digit. That number is the only one that matters to make the decision in step 2. So the number to the right of the round 2 digit is the number in the fourth decimal place, which in this case is 6. Now step 2 says if that number is 5 or more, round up by increasing the round 2 digit by 1 and leaving off the rest of the digits to the right. I'm not going to read the rest of step 2 because that is exactly the situation we have here. The number to the right of our round 2 digit is 6, which is more than 5. So we're going to round up by adding 1 to the 5 to get 397.496. This is the answer, rounded to the third decimal place. Now what about example 1.2? Example 1.2 says, round the number 14.342999 to 1 decimal. Okay, so this is the shortest way to talk about our decimal places. 1 decimal refers to the first decimal place, 1 decimal place to the right of the decimal point. So in this case, that is this number 3. So 3 is the round 2 digit. Do we always have to indicate which is the round 2 digit? No, we don't, but we're just reviewing right now. So we're going into the details a little bit. So look at the number in the decimal place directly to the right of the round 2 digit. That's step 1. All right, so the number we're going to be looking at is this 4. If that number is 5 or more, round up. Nope. If that number is 4 or fewer, so we're going to start there, round down by leaving the round 2 digit as it is and leaving off the rest of the digits to the right. So that is the situation we have here. The digit to the right of our round 2 digit is 4. That's 4 or less. Some people say it as less than 5. And so we're just going to cut off everything to the right of this 3 in the first decimal place. And so the answer is going to be 14.3. Now, example 1.1 shows a rounding up situation. It's called rounding up when you have to add 1 to the round 2 digit. That's because the resulting number is a little bit larger than the original thing. Example 1.2 shows a rounding down situation where you take off the extra digits and you leave the round 2 digit the same. That actually results in a number that is slightly smaller than the original number. So there's a cost to rounding. It's a mathematical cost though, and we'll talk about it when we start talking about calculations. So remember I said that the basic algorithm needed to be modified somewhat for certain cases, and this is one. So an interesting case occurs when you have to round up and the rounding 2 digit is 9. The problem is when you add 1 to 9, you get 10, right? So in that case, you can't stop with the rounding 2 digit. You have to account for that 10, right? And the way you do it is you add 1 to the next digit to the left of the rounding 2 digit. The rounding 2 digit itself becomes 0, which you can choose to write or not. So taking a look at example 1.3, round the number 720.0759844421 to the fourth decimal place. So the fourth decimal place has a 9 in it, and we look 1 to the right. In our rounding algorithm, we have to look at the digit directly to the right, which is an 8. That 8 is more than 5 or more. So that means we need to add 1 to this 9. But when you add 1 to the 9, you get 10. When that happens, what you actually have to do is change the 9 to a 0 and add 1 to the digit immediately to the left. 5 plus 1 is 6. And then everything else to the left remains the same as the original number. Okay, so you get 720.0760. Now, 720.0760 is exactly the same thing as 720.076. And most homework programs, if you put the 0 or not, they'll accept either one because the 0 is just a placeholder in this case. It doesn't add any information to the number. Now take a look at example 1.4. Example 1.4 says, round the number 3,049.9999999 to the hundredths place. So the hundredths place is the second decimal place. And we see the digit to the right, directly to the right, is a 9. That's 5 or more, so we're going to have to round our round to 9 up. Adding 1 to that 9 gets us 10. So that is going to put something into this place, right? However, we still can't stop there. That 9 being added to by 1 gets you 10, which then is going to add 1 to this 9. What do we do then? We continue with the algorithm. This 9 needs to have 1 added to it. That's going to give us 10, which means we add 1 to this 4. We get 3,050.00 to the hundredths place. So you have to keep going to the left as long as you have to in order for the number to come out correctly in the end. So to the hundredths place, this actually rounds to 3,050.00. This could absolutely be written as 3,050 with no decimal and nothing after the decimal because there's nothing but zeros after the decimal. So when it comes to 9s in the round 2 digit place, they cause problems. You have to keep going to the left until you get to a point where things are not adding 1 to get to 10. Moving on. Large numbers crop up frequently in business and are often rounded to decimal places that are to the left of the decimal point. In that case, the rounding process works the same way as it does. You use the same algorithm, starting with the round 2 digit and looking at the digit directly to the right. But instead of simply leaving off digits to the right of the round 2 digit after you do the rounding, the places between that round 2 digit and the decimal point get filled in with zeros. All right, so what does this look like? Let's take a look at example 1.5, which says round 38,497.4201 to the thousands place. Okay, so the thousands place, remember, from figure 1, is the 4th place to the left of the decimal point. So the round 2 digit in this case is 8. Now, having identified that, we're going to look using step 1 of our algorithm at the digit directly to the right. That's a 4. That 4 is 4 or less. So we need to simply leave off everything to the right of the round 2 digit. But in this case, we can't just leave it off because that would be misleading. If we left it off, we'd get 38. In this case, we're going to fill in with zeros between the round 2 digit and the decimal points. So this number could be written just like this, 38,000. It could have a comma there. It may or may not, depending on how big it gets. It could have a decimal here. It could have zeros after the decimal. Those don't actually matter. When you are rounding to the thousands place, what you're looking for is zeros anywhere to the right of the thousands place, and that's what you have with 38,000. Okay, how about negative numbers? Well, with negative numbers, just round as if the number was not negative and then put a negative sign on it. So if you start thinking about it being a negative number and then you say, oh, am I adding 1 or is it subtracting? Don't do that. Just look at the number as if it did not have a negative sign. Do the exact same thing you would do to it if it didn't have a negative sign, and then leave the negative sign on it. So let's take a look at example 1.6. Example 1.6 says round negative 758.916 to 2 decimals. So the round 2 digit, when you're talking about 2 decimals, is the second decimal place. In this case, that's a 1. Step 1 of our algorithm says look to the digit to the right. That's going to be the 6. 6 is greater than 5, so we have to add 1 to the 1 in the 10th place. So do that. 758.92 is going to be the answer, and it's negative because this number is negative. So simply act as if the number was not negative, but make sure to keep it negative if it starts out that way. The final rounding matter that often comes up in business contexts is rounding dollar amounts or other currency amounts, because a lot of times the calculations you're doing in business involve dollar amounts. These are going to be rounded usually to the nearest dollar or the nearest cent, even when the calculations result in many more decimals. Now, they could be rounded to the nearest 1,000 or the nearest million. You could certainly do that with dollars. But the things we are going to concentrate on here is when you are asked to round to the nearest dollar or the nearest cent. So since dollars are counted in ones, rounding to the nearest dollar means rounding to the ones place. So you're just going to round to the decimal place that is to the left of the decimal point. Rounding to the nearest dollar results in a whole number then. So a whole number is any number that doesn't have anything but zeros after the decimal point. So any number could be written with a bunch of zeros after the decimal point. But if there's only zeros after the decimal point, that's a whole number. It doesn't have to have the decimal point, and it doesn't have to have any zeros. Now, so the nearest dollar means the ones place. What about a cent? A cent is 1/100th of a dollar. So you keep track of cents in the hundredths place. So rounding to the nearest cent means rounding to the hundredths place, which is the second decimal place. So let's take a look at a couple of examples just to make sure we have this straight. Example 1.7 says round the dollar amount 57.085 to the nearest cent. So if you're talking about the nearest cent, that is the hundredths place. So the hundredths place is going to be the second place after the decimal point. We look at the digit following, which is 5. That's 5 or greater, so that means we have to round up. We're going to have to add 1 to this 8 and get $57.09. Once we round it up, we actually added a little bit of money on. So taking a look at example 1.8, round the dollar amount 33.2275 to the nearest dollar. Okay, rounding this to the nearest dollar means rounding to the ones place. The ones place is this place, first to the left of the decimal point. We look to the next decimal place, which is this 2. The 2 is less than 5, right? It's 4 or less. And so we're not going to round up in this case, we're going to round down. That simply means truncating the number at the decimal place. So it's $33 to the nearest dollar. So you can see here that by rounding down, we are actually missing out on between 22 and 23 cents. Right? So that's a good portion of a dollar. So here we've rounded off quite a bit. You might do this to communicate basic dollar amounts, but you would not want to round it this much if you were using this number in a further calculation.